Good morning, everyone. I welcome all of you for this session on logic building, scripts, and function. Okay, so we will try to understand how MATLAB can be used to build the logics and the programs written in the form of scripts and an additional program known as a function that can be referred to from the main script or the main program in this session. Okay, so let me move on to the introduction or the outline. All right, so what we will try to understand in this session is to uh, execute the MATLAB commands in the command prompt. Okay, and how the series of commands that we execute in the command prompt can be put in a set to make a main program or a script. Okay, so for that, what we have to understand is how the logics for the program have to be built first. Now, to understand the logic, we have to basically consider
through
a specific program. Okay, for a specific program to be written, you have to take a specific problem. Okay, now if you take a specific problem, it will have its associated variables, right? So those variables are the inputs for the logic. So all about such logic building and how a logic building can be done in that for a specific problem will be understood in the logic building discussion. Okay, now there are two fundamental statements in MATLAB that can that form the basis for building the logics. Okay, so they are primitive and trivial to most of the programming language, and those statements are the conditional statements and the loops. So to build any logic, you need to have statements which check for certain variables, or it's a check or a comparison between two variables. Okay, so conditional statements form very much important uh, basis for any logic building. Then to continue with that, okay, if you have a repetitive checks, okay, or you need to run a series of commands repetitively, then you have to go for the loops or the loop commands. Okay, now most of the programming languages have these loops. Okay, to name a few, you have for loop, while loop, so on and so forth. All right, next, after we build this logic, okay, right, we will understand the scripts and functions. For most of the programs that we write, okay, we need to write a series of commands, okay, which are generally algorithmic in nature. The series of commands will be algorithmic in nature because we have to pass information from the output of one command to as an input to the next command. Okay, so those sequence of commands that you write, okay, are written through an editor. Okay, you write it in a MATLAB editor, and that editor in MATLAB is known as a script. Okay, so the editor will contain all of these commands. Okay, and those set of commands, okay, are written in a editor, and this editor, okay, will contain these statements, and this set of statements will form a script or a program. Now, in addition to that, what we try to do is we can also link the inputs of a set of codes, which is a program, to uh, to be passed to a set of codes in another program. Okay, suppose you have another program, right, which has a series of statements. Okay, so that program is a separate program. All right, so you will have program A and program B, and for that you have to pass the information from program A to B. Okay, then if you try to pass a separate module of a program A to program B, then the program B is a subprogram, and so it will be termed a function. Functions are also scripts, but it will have an additional advantage, okay, that I'll try to cover in this concepts of functions and script later on. Next, we will go for few case studies. Now, when I say case studies, we will try to take a problem associated with mechanical engineering, and I will try to explain how we will build logic to write a script and a function to solve that problem. All right, and after that we will try to understand the overall sense of how logic can be built, a program can be constructed, and the output can be obtained by concluding. Okay. So first let us try to go for the introduction to logic building. Now, if anyone has any questions, they are free to stop me during the presentation. Okay, and we will try to take the questions also after the session is completed. All right, so if you have any questions, you can also type in the uh, chat, right? I'll try to answer that. So if I have any questions, I can try to in the take it up in the chat, right? Otherwise I will keep explaining the programs. Okay, all right, so let us understand how we can try to build a logic. Okay, in generic sense, logic can be built if you have a sequence of small computation steps. Okay, like you use your calculator to compute using few arithmetic operations, okay, to compute the value of variables using few arithmetic operations, and those are known as your expressions, right? So if you have the first expression, let us say a is equal to b plus c, then you're trying to use the value of the variable b and c and compute the value of variable a using the arithmetic operator plus, right? So that is one command. Okay, so then this information has to be passed onto another variable, right? Suppose say d is equal to a. So if I say d is equal to a, then I will have the value of d to be a itself. So you have now two commands that just got a message passing or the information passing from the first command to the second command. So if you go to MATLAB. Okay, in the command window, okay, you can type a is equal to 3 and b is equal to 2 and c is equal to a plus b. Now, what you see here is that I've written a series of commands. The right hand side of the each of this command, which is now an equation, okay, has an expression. So this is an expression for me. A plus b is an expression. Okay, if that expression is equated to the left hand side of the variable for which it is assigned, then you will have an equation. So when you say c is equal to a plus b, a and b are variables, right? And c is a value which contains the sum of a and b. Okay, now what you have to note in MATLAB is you have just written a series of commands. So each line that you write after the greater than symbol, after it is executed, you will have a command to be executed. Okay, so if a is equal to 3 and b is equal to 2 and c is equal to a plus b, then you will have the value of c contained as a sum of a plus b. Now what is the logic here? If you see this logic, we have just accomplished a question where we wanted to add two numbers, and what is the answer that we expected is the sum of two numbers. Okay, so in command prompt, as we have seen here, you can see the sum of variables, okay, just got assigned to C. So if you want to do this repetitively, you can say D is equal to A minus B. Now once you see D is equal to A minus B, you again had a new computed command, okay, where you got the value of D to be 1, right? So if you see the sequence of commands that we have written here, okay, A is equal to 3, B equals 2, C equals A plus B, and then D equals A minus B. So these are the series of commands, right? So if you want to do this in one go, okay, if you want to do this in one go, what you could do in MATLAB is write it up in a single line. Okay, so it just executed that in a single line, right? So you had 4 commands and it got executed in a single line. Fine. So now each of these values of the variables on the left hand side in all of these equations are stored in the workspace. As we know, this is a workspace where immediately whatever variable you type in gets stored. Okay, so once it gets stored, you will have all the values of the variables contained in it. So you have computed and you've written a series of commands, right? Now what happens if you had lot of commands to be executed? Okay, so you had lot of commands to be executed. Then what you will try to do is to build such logic. Okay, you will write what is known as an algorithm. You'll write what is known as an algorithm. Now what is algorithm? Algorithm is a series of statements that can be read in a human form. Okay, so which is understandable to most of us because algorithms are written in a common language. Okay, so you will say assign the value of a to 2, then assign the value of a to 3, and assign a value for the variable b. Okay, so its value will be 2, and you sum those variable and assign it to C. So you'll write a sequence of human readable or human understandable statements known as algorithms. So once you understand this algorithm, you will have a flow of information. first you have to do this computation, next you have to do this computation, this you have to do, and then finally get the value of your C. Okay, so now if you build such algorithms, what you will try to do is an easy way to understand than to read a series of statements where we can understand with your common language. You will try to construct what is known as a flowchart. Okay, um, because pictures can depict information very quickly as compared to statements that is written for about pages, right? You will choose the first approach where you will show the information exchange between the variables in a diagram known as a flowchart. Okay, in flowchart, you will try to give a very compact flow of information between variables where the variables exchange the values, right? So if you see a flowchart, for example, let us take this flowchart. Okay, this is a flowchart. Now, what you will try to do is you will assign a value for I equals 2. Okay, then once you assign a value for I equals 2, you will check whether there is a certain condition that you have to check, right? So we'll check whether I is less than or equal to 6. Now, if you check whether I is less than or equal to 6, yes, it is to start with, then you will print the value of I plus 1. So you will print first as 3. Okay, then you will increment that by 2. So 3 plus 2 will be 5, and 5 is less than 6. So you will print that 5 plus 1. You will print 6. Now 6 is printed. Yes, now 6I is equal to 6. Then you will increment that by 2. So it will become 8. So I is not less than or equal to 8 is not less than or equal to 6. So you will stop. So you can see here that this kind of a compact representation, okay, of information passed from variable to variable, okay, by taking certain decisions and taking certain loop constraint, you can depict the flow of information in such a way that you will get the final output of I as 6. Okay, so these are two important logic building blocks. So what you'll have to do is, first, if you have to understand the program, you have to first understand what is to be computed. Okay, what needs to be computed and how you will compute that. So these are the two questions that you need to understand. Before any program is started, you have to understand the definition of a problem. Okay, the objective of any code written by a programmer is to first understand the definition of the problem, okay, and see how this problem can be solved, right? So how a programmer thinks while he develops any program is by undergoing an iterative process of questioning. Okay, he tries to question himself whether he understands this, and tries to gain his experience by writing piece of codes that he understands, and finally he will try to assemble that. Okay, and try to finally solve the problem. One day the problem will be solved and you'll get the solution to the question that you had in mind in a time before when you could not understand, right? So if you think of any logical building approach in any programming language, you will have algorithms and flowcharts written for a small set of commands that you understand, where you will try to pass on the information. Okay, now the next difficulty that one would try to overcome is how I can try to build a code, how systematically I can try to build a code, whether it is efficient code or it is a code which runs pages together, or how this code will help me to solve the problem. Am I stuck up in a loop, and so on and so forth. So these are the difficulties that programmer would try to go through. Okay, so the other approach that one would like to develop for any program solving uh, uh, approach, is that first the programmer will try to define the problem itself by himself. Okay, the problem is simply a question. Okay, he'll pose a question for himself, and once he poses a question, he wants a solution to that question, which means he wants an answer to that question. Okay, so a question will have a certain number of uh, variables that he wants to actually see the relationship with. Okay, and how it is related, and the answers is what he will try to compute and get satisfied that yes, this is a solution to the problem that I have. So if you see the logic building approach, the programmer will try to think of a question. Without a question, there is no point writing a code or a program. So you have to know a question, understand the question very well, or if you have a concept. Okay, so these will generate a set of series of inputs that you will try to generate within your imagination or your framework, where you can try to think of many variables. Okay, and then you build on what logics you have to try to use to relate these variables, so that you will get the solution, which is the output that you want. Now, since it is an iterative process, sometimes you will try to make up commands that will give you a solution which doesn't make sense in reality. So what you'll try to do is you will try to keep looping up here by, you will check and you try to practice, write some codes. Okay, and you'll keep looping up. You ask the same question, you won't get the answer. So you will become very systematic and you will have very disciplined effort. Okay, so in the process of writing any code, you'll have some experiences, you'll have some failures, and you will have to be patient to solve such problems. Okay, so this is an good approach, okay, for building a logic. The next approach that you have is the block diagram approach. Okay, so the next approach is what is known as a block diagram approach. Now, if you can construct such flow chart, okay, and make it as a block, within a block where you will have a lot of logics, and try to construct different blocks laid one next to each other, okay, such that you will have a looping as a feedback, right? Then such type of approaches are used in control systems. So in logic, after you build the logic through algorithms, flowcharts, using your conditional statements and looping statements, you will try to make a block out of this, and you'll assemble series of blocks with blocks which are connected in such a way that you have a series of information that flows through to get you what is the desired input that you have, what is a standard input that you wanted your program to take, and what is output you expect from the program. So this is in a nutshell to tell that you have to take small pieces of commands, assemble them to make a block, and each of those blocks have to be connected, and you will have an input variables to a program, and the program will have to give you an output or a solution which is which makes sense according to me. Okay, it should make sense. Okay, so these are some of the important steps that one needs to actually follow to build a logic. Okay, all right. So once you build this logic, okay, now we will try to understand some of the conditional statements and looping statements. Okay, so that these statements that is used in MATLAB, such that first we will understand the syntax of the statements and how it can be used. Okay, now let us take this just an outline for this conditional statement. Okay, now most of the programming language use this conditional statement. So these statements are if and if else statement. Okay, now if you take this condition statement, which is an if statement, all right, now let us understand how this if statement will work. Now if I say if A is greater than B, this num to string of A, sorry, A, and I will say end. If I write this small piece of code, which is a conditional statement, I'm just doing a comparison between two variables, A and B. Okay, so if I compare A with B, now the previous value of A was 3 and the previous value of variable B was 2. Now A is greater than 3. Yes, 3 is greater than 2. So you will try to display that value of A, which is 3. Now what is that we did here? We did a comparison. Now let us say if A is less than B, this num to string, or I can say this error, and then say end. What actually happened was that it did not give me any output, because that I have had a comparison, okay, where A was not less than B, it was greater than B, so it did not display the error. Okay, so if you see, what did we understand from this code is that a comparison, when it is successfully compared, will execute the statement after the comparison succeeds. Okay, so you will have A greater than B, then you will try to display A. Yes, it obeyed. If A is less than B, no, it did not happen, so it will not execute this piece of code and the statement will just exit. Okay, so this is the simplest comparison, which is your if statement. Now you can also do an additional check, right? In the previous problem, if you see, we did A less than B and it did not display anything. So what I'll try to do is, if A is less than B, we'll say this is greater, A is lesser, else this is greater, and end. So if you see this piece of code here, now since A was greater than B, you could say A is greater always. So that is where it took the else condition here, okay, that A is greater now than B. Okay, now suppose I assign A is equal to 1. Now you can see on the workspace that A is equal to 1. So if A is equal to 1, and if I try to execute the same piece of code and run, now you will see that A is lesser, right? So from this, you will see only when the comparison succeeds, you will have a series of commands that will be executed according to the comparison. Okay, so since A is equal to 1 and 1 is less than B, you will have A is lesser, right? B was 2, the value of B was 2, as we assigned in the previous case. Okay, so if you can see this conditional statements, you will have if statement and if else statements. Okay, now these form a very important basis for any logic building. Now, if you consider the next statement that we have is a loop statement, which is a for statement. Okay, so if I take this for statement here, for I equals 1 to 10, this num to string I and then say end. Try to execute this statement. You will see that the value of I repeatedly got incremented. Okay, it started with 1 and it got incremented, and for before every value of I that got incremented, you are trying to display the value of I. Okay, so if I starts with 1, you will have 1, then next it gets incremented, so it will become I plus 1, right? I plus 1 would be 1 plus 1 2, and then you will have again 2 plus 1 3, so on and so forth until I becomes 10. So that's the maximum value that I've put. So if you know till what value of I that you have to stop the incrementing of I, then you can use a for loop. That means a for loop is used provided that you know the countable number of times a loop has to be executed. Sir, is it visible? Is the screen visible, sir?
Santosh, please reshare. That is not visible. It's not visible.
Hello?
It's not visible, Santosh. Please share the screen. I think someone tried to
I
share
think
his.
you will
Yeah.
have to go to present now.
Yeah, present once again. Once again, you have to start presenting. Now, request
Screen not
participants.
visible.
Yeah, screen is not visible. Okay, now it's coming.
Okay, sir. Am I audible now?
Yes.
You are audible, but still not.
But
Screen is
still,
not
no.
being
It will,
visible.
please go to the document.
Okay.
Yeah, you have to present, just
Yeah,
present,
present. Yes,
Santosh.
yes. You have to go to yeah. Now it's fine. Now it's fine. It's working.
Yeah, we can see.
Okay. So you can see the PowerPoint as well as the MATLAB, right,
Yes,
sir?
Yeah, now
yes.
it is
Okay.
fine, Santosh.
Now
Go
it is
ahead.
fine. Now it's
We
fine.
are
Go
seeing
ahead.
the
Go ahead.
slides.
Yes.
Okay.
Go ahead.
So we will go for the next statement, which is a for statement. So did I cover up till for statement? Hello?
No, if statement.
Only,
If
only
statement.
if
Only if
and then.
statement. Yeah.
Only if statement. So
Yes.
if A is greater than A is less than B, A is lesser. Till there it's done, right?
Yeah. Correct.
Okay. So let me go for the for statement again. Now in MATLAB, if we use CLC, it will clear the screen, the command window screen, and if I use clear, it will clear all the variable in the workspace. Okay. So the loop statement goes this way. If I equals 1 to 10, I'll say disp of num to string of I, and then say end. So if you see this loop statement, for every value of I that got incremented, you are trying to display the value of I, the previous value of I. So if you know the number of times the loop needs to be executed, then you can print the value of I. Okay. So for loop is used only when you have certain number of variables, certain values of variables that needs to be incremented for a known number of times. Okay. So if you go for a while loop, suppose you go for a while loop, okay, while loop is very similar to a for loop, but it's a conditional check loop. Okay, so you will have to satisfy a certain condition before you get into the loop. The syntax of while is very similar to syntax of for. What MATLAB does is it has a very simple syntax. Instead of this word for, you will try to replace that with while. Okay. Now, if I write the code here, A equals 2, B equals 5, while A less than while A less than B. Okay, while A less than B, A is equal to A plus 1 end. Before that, what I'll try to do is before end, I will say this is, or I can say num to string of A and end. Okay, so if you see, what did we do is we assigned the value of A and B first. A was 2 and B is 5. A was less than B to start with, so it got into the loop and it computed the value of A immediately, incrementing it by 1. So A becomes 3. So then you will display 3. So you will have the first time the loop that displays the value of A as 3. Then it loops up again and checks whether 3 is less than 5. Yes, it is less than 5, so it prints 4. And when 3 becomes equal to 5, okay, it happens after the incrementation in the last loop, and so it will print 5. Okay, so in this case, what I did was that I did a conditional check in the loop to print the values of the variables. So this is a conditional check loop. That means only when the condition is satisfied, the loop will execute. Right. So then we have what is known as a nested loop. In the nested loop, you will have a loop within a loop. Okay. So you can put two for statements within it. Within the first, you can put a for statement within a for statement, or a for statement within a while statement, or a while statement within a for statement, so on and so forth. So such kind of loops can be used to address the elements of a higher dimension matrix. If you take a 3x3 matrix, you can address the elements of all of these elements of this matrix using a nested loop. So that is very similar to the logics that we see in C program, where we'll try to do matrix computation by matrix multiplication or addition, so on and so forth. Okay. Now, once we have this, we will try to see the important characteristics or important features, or you will have features of these scripts. So these are, as we understand, a series of MATLAB commands. Okay, the script is a series of MATLAB commands, so it is a program. Okay, so if you want to build a script, what you have to do is first leave this command window and go to a blank script. You can see in the screen a blank script. Click on the blank script. Okay, and start typing up these commands. So all those commands that are typed in the command window has been typed again in the script. Okay, so these are the series of commands that we have. Every time I run this script, I will try to first clear off all the variables in the command window, clear all the variables that is there in the workspace here, and then I will start afresh to assign the value of variables as an input, where a equals 2, b equals 5. Then I will start a computational block. This is computational block where I do computation and try to do a display. Okay, so if I take this editor and populate that with this series of sequence of commands, then I can try to save that script. Okay, and call it as MATLAB while script. Once I do that and save that, so it will get saved. Now I have successfully created a script in MATLAB, and when I try to run this script, you will see. Okay, before I run this, I will show you how you can try to run it one by one. So if I set a point here on the screen, suppose I set a point here, you can see two red circles appearing. So if I run this program, it will go step by step. So if you see, at first it did CLC, and then it is doing clear all. Then if I press continue, it will go to the next series of statements here. So you can see once it jumped from here to here in a script, it assigned the value for A and B, and it stored the value for A and B in the workspace here. Okay, so then if I start continuing this, it will print, okay, as long as A is less than B, and then it will stop. Okay, so if I take this out and continue, it will stop. Okay, so you can say quit debugging, and you can see a step-by-step compilation of the program. So if I take out these breakpoints here in the editor and run the file in one shot, it does an infinite loop. Okay, because A is always less than B and I'm not doing anything here. So, okay, stop now and exit. All right. So if you see that because of the conditions that you implied or you could type while comparing A and B, you could run into an infinite loop, right? So you should always be careful with the condition loop, right? Now, if I say A is less than B, then say A is equal to A plus 1, then you will have incrementation of A for every time the loop runs, and then you can see the values of A printed. Now you are not running into the infinite loop because you did not increment A before. Okay, so this is how a script can be created, and you can try to run the script, okay, by introducing breakpoints, set points, okay, debug the code one by one at a time. Okay, now okay, so if a script file is run, the commands are executed in order, right? The output of the script file is displayed in the command window. We saw that. So whatever output that we try to display within the script file got displayed in the command window. Okay, so you did a display command, you typed a display command in the script, and so you get that values of A printed in the command window. Okay, so script files are typed in a text editor. That's what we have done, and you can see that the name of the script ends with this extension .m. Okay, .m means for M file or a MATLAB file. All right, and all the variables that is defined within the script is contained within the workspace. Okay, the values of the variables is contained within the workspace. So now we have understood how a script can be constructed in MATLAB. All right, the functions. Now, if you take, as I've explained before, that if you take program A and program B and you want to pass information from program A to program B, you have to write a program B which is separate and in an editor, okay, and gain the access from program A and use those values of variables where you have an access from program A, and then try to manipulate those variables and send those variables, which are computed variables, back to the main program. So that's where the function files are used. So function files will pass on the arguments to the script file within which it is called. Now there are certain constraints in MATLAB that you have to follow. The function file name must be the same as the file name of the program that you create. Okay, so the function file name cannot be arbitrary. It has to be the same as the file name or the script file name that you try to save in a particular directory after it is being created. So the function files uses local variables. So local variables will not be displayed in the workspace. Okay, so if you run a script, you will see all the variables being stored, the values of the variables being stored in the workspace. But if you see, if you create a function and try to run that function, you will see the variables which got computed within the function program or the function script will not be displayed in the workspace of the calling script. Okay, and the other constraint here is that MATLAB will only allow the extension of the function file as .m files, and the function files have to be always saved in the same directory as that of the script file that you created. The script file that calls a corresponding function and the function file which takes the arguments from the script file have to be saved in the same directory. So these are some of the rules that you have to follow while creating your scripts and functions. Okay. Now let me just give an example. Okay. Now what I'll try to do, I will try to develop the same program, same script. Okay. But I will call a function in the script. Okay. So we will construct a function first and call that function within the script. Okay. Now I have stored this script, MATLAB while script, that's the first script, in the current folder. Okay. So I have to create another script, okay, with a function name, okay, which also have to be saved in the same folder, here. So I will say function, value of a function is equal to compute of a. A is equal to, value is equal to a plus 2. So this is how I create a function. Now if you see here, this is a syntax for a function. I will have a function where a computed value name is VAL and the name of the function is compute. So if I use the name of the function as compute, then I have to save this function file with the same file name. So it automatically comes here as compute in the same directory, okay, where I've saved this MATLAB while script that I created a while ago. So I will try to save that here, okay. And if I try to run this function script, it is not going to run. And the value of a that you, okay, I will give you the value of a that you actually created in the main program still holds good in the workspace. So whatever, if you run a function script, it will use a local computing environment and it will not display the value of this variable val in the workspace, as I've already explained in the previous slide. Okay, so you will use this function compute, okay, then you will say compute had a plus 2, right? So we'll say compute of a, and a is incremented by 2. So compute of b, okay, so I will send an argument which is b to this program here, or I can send the value of a itself. Yes, do you have any questions?
Sir, can you repeat it? It's not clear actually. Can you repeat once again?
From
Function only, the function we
what?
try to link up.
Okay, okay. Okay, so if I create a function, okay, if I create a function, the function is again a script, right? So I'll say function equals the name of the function, the value of the function which it has to return back, and I will say the name of the function is same as the name that you will try to save, okay, which is compute.m, and it will have a certain arguments which it takes in from the main program because it is called here compute of a, right? So that value is passed on here, and the value of the variable that it passes is the value that it took in and got incremented by 2. So VAL Now for a equals 5, suppose I take a equals 5 here, 5 plus 2 is 7. So a will now get a value of 7. Is that clear now? Yes?
Yes, sir, somewhat clear, but I'm not able to get clear. That the value which is the variable you have mentioned, right? val.
Yes.
The value you are assigning as a function a.
Yes. The value that the function have to return, right? VAL is the value that the function will return.
Okay.
All right.
A can we give any other in the function, the means parenthesis which you have given a, can we give any other thing or we have to give only a?
You can take any other variable. You can take it as C or D or anything. It is up to you. Okay. All right. Is that clear?
Yes, yes.
Okay. So you had this doubt, right? That it need not be A, because I took it as A because I wanted to pass this value of A that is there in the main program. Okay. Where you could understood that is a passing variable. Okay. But if you take, you might take it as some V or anything and then V plus 2. All right. Now, if I run, the program runs. So you can see that V, the value of V that it got computed within the program did not actually appear in the workspace when I could run this main script. All right. Hope this should give you a good understanding. Okay, fine. Any other doubts or clarifications? Yes. Can I proceed?
Present the screen. Santosh, present.
All right. All right. So once we have understood how to create a script and a function and how a function can be called within a script, right? We will try to use both of these scripts and functions in the to build a logic or to build a logic to solve a problem. Okay. So let us take a case study. Now let us take a case study. Okay. Now case study means that you will be given a problem, okay, in the form of a question, and you will try to think how you will program to obtain an answer that is the objective of the question for which you have been that has been asked to you. Okay, so we will try to take a case study. Now let us take a case study of a control system. Okay, so I've taken an example or a case study. Okay, now if you take this control system, most of us know what is a control system. Okay, there are two types of control system: an open loop control system and a closed loop control system. Now if you take or consider a case study where you have taken a closed loop control system. Okay, closed loop control system. Now what is the objective? The question that you will pose is that given a certain input to this control system, you will do a comparison here, okay, and send an error signal to a physical system which has certain transfer function, okay, and you will expect a certain output from this block which has certain transfer function, and this output is now sensed by a sensor and is given to this comparator. Okay, so you will have an input to the system and the output to the system. Will compare the input with the output, obtain the error, give it to this block, okay, which is a physical system which has certain transfer function, and you expect the output. Now, as long as the input and the output that is measured is same or different, when I say I'm sorry, are different, you will have an error signal, which is a comparison between the input signal and the output signal. So if there is only error, then that signal is sent to this block, which has certain transfer function. And then you'll expect the output from this transfer function. Now, if you see this block diagram in control system, okay, which is posed as a question to you to find out what is the error that you will send to this input block. It is an error that you will send to this input block. Okay. The error only exists only when input and output are not equal, as we can understand. And if they are equal, then there is no error. And if there is no error, there is no signal sent to this block, and the block will cease to give you an output. Okay. Okay. So if you just take this block diagram, okay, this block here will have a certain transfer function, and we all know that transfer functions are represented with respect to a Laplace variable s, small s here, as seen. Okay, and you'll have a feedback sensor which has a transfer function h of s that will be equal to 1. So this is a closed loop control system. So if you have a desired input given to the system, you expect a desired a specified input. I'm sorry, if you have a specified input given to the comparator, okay, and you will have a specified desired output that is got from the block. So you will have a comparison, and so you will have an error signal that is going into the block, and this is a loop, so it loops up. So your objective, or the question that we have from this problem, is how an error varies in time. Now for this, there's certain inputs that you will try to make it up. Okay, then you'll ask, what is R of S? What kind of an input? A trivial input for such system would be a step input, okay, like a unit step displacement. Okay, just imagine that you're just trying to climb up the stair, okay, in your house or in your college or offices, right? So that is the input that is given to the system. And what is the output that you expect from the system? The system also have to achieve the same value of the input that you get. So I'll take a unit step input, and I will have a Laplace transform of that is given by 1 by s. Okay, and you want to get what is output, which is a function of time, because we want, the objective of this problem is to compute the error in time. Okay, so the error will be c of t here. So if you take the closed loop transfer function c of s by r of s, that will be given by g divided by 1 plus gh. So g is 1 by st, okay, 1 by st, and h of s is 1. So if you substitute these two transfer function values here, you'll have a closed loop transfer function c of s by r of s is given by 1 divided by 1 plus st. So this is a closed loop transfer function. Now what is the advantage of closed loop transfer function? What the advantage of such closed loop transfer function is that you will capture the system behavior, or the output. You will get the output of that system, which is c of s, okay, provided you know what is r of s, what is the input. So if I transfer r of s this side, I will have 1 divided by s into s1 plus st. So the output c of s is equal to 1 divided by s into 1 plus st. Now if I use inverse Laplace transform for c of s, you will have the output c of t given in time. Okay, taking a Laplace inverse on both sides here, on both sides of this equation, I will have c of t equals L inverse of 1 divided by s into 1 plus ts. So if I take a Laplace transform of this and simplify, I will get the output here for a unit step that I apply in time as 1 minus e power minus t by minus small t by capital T. Now this capital T, okay, is a measure of time constant of a system. If you can recall, it is a measure of time constant of a system. Now time constant is physically a time constant is a measure of how the system can respond, how fast the system can respond. Okay, if a time constant is less, the system responds faster. The time constant is more, the system responds slower. That means if you apply a step input here, if the time constant is the least, then you will immediately achieve the same value of a step as an output from the system, final value of a step value as output from the system, okay, as quickly as possible. So therefore the error here will be the output that you measure. So that is in function of time as 1 minus e minus t by minus small t by capital T, and the input was step input, which is r of t as 1. So the error will be 1 minus of 1 minus e power minus small t by capital T. So this is your error. Now what we'll try to do is we will try to compute the error for this problem in time. Okay, physically if you see, this is a block representation of a closed loop control system, especially the first order system. Now physically, if you understand what is that error signal, which is a physical, can you expect physical insights on what is error signal, then you have an answer. Suppose you take a dashpot, okay, the force applied on a dashpot is C into dx by dt. Now dashpot can be thought of as a simple, it's a cylinder within which you will have a movable piston, right? So the force that you apply on the piston will be equal to C times, where C is your damping constant, okay, times your velocity dx of t by dt. So that is your force, okay. So the force now that is applied onto this dashpot is C into dx by dt, okay. All right. So what we'll try to do is we'll try to get this. Just 1 second, huh? Hold on, just 1 second. Just 1 second. Okay, so the force that we see here that is coming onto the dashpot is represented by this transfer function. So the force that is applied is an error force that is applied to the dashpot. So that is what we see as a physical significance. Now remember, all of this the theory that we have built around in this closed loop control system for a first order system response is with respect to the initial condition that is specified as displacement at time t equals 0 is 0. So you can solve this differential equation to get the value of your error force. What is the objective of this problem? Is that you will compute the value of error as a function of time. So let us make a script where you will try to understand how an error can be calculated. So I will start a new script. Comment this, call it as inputs. Now I will assign a variable time constant t equals 1 I'll begin this computational part. So these are the inputs to the problem. So only input to the problem, it is a simple problem. So only input to the problem is a system parameter, which is a time constant. It is t equals 1. Okay, so I will have a computational block here. Now remember, if you try to use double percentage symbol, it will make it as a section. So I can make this as a section. Okay, so you can, so that's a good programming practice if you try to use a double percentage symbol. And you will say, you will start with time equals 0.1. So that's a time that you will start. And r of t equals 1. If I take r of t equals 1 here, yes, r of t equals 1. So that is your r of t. Then you will have exact solution. X of t equals 1 minus exp of minus t by capital T. So that's your x of t. Error, the error in time will be r of t minus x of t. So I will try to comment this. This is time in seconds. Of time in seconds as an independent variable. We'll have time here as input or specify by displacement meter. Put as desired displacement meter, and then I can write this as error as a function of time in meters. Okay, so this is what I do. Then what I'll try to do is input, so I print outputs. To print outputs, so I'll have S equals time t of S. Num to string of t. Now I have r of t. Okay, I'll say r of t equals num to string of rt. Of rt. I'll say x of t equals num to string of xt. Remember, if I put a triple dot, it will go to the next line. Otherwise, you'll have to write the statement that goes through along. Okay, so use a triple dot. You can see the entire code in the same screen. And error m equals num to string of error is and I'll save this, call this as A, first order closed loop control system, the same directory. Okay, so that is the script that I've built here. So the objective of this script is to run the obtain the value of error in time. Okay, So I will run this script for you. You can see here that at time t equals 0.1 second, your input, which was a unit step input, was 1, and at time t equals 0.1, this is the output. This is the output x of t. Okay, and you will have error as 0.90484. So there's a 90% error. Okay, so what you have to do is, again, suppose that you say that at time t equals 0 and rerun the code, you will see that error is 100% because the output has not reached the input value. So error is 100%. Okay, now if you take a sample time of 0.5 seconds and rerun the code, you will see the error is 60% here. Okay, so now you will see that we have computed the value of error using this expression. Okay, now if you want to have a multiple times that this program has to run, okay, I will say print program outputs multiple times. Okay. Print program outputs multiple times. I'll say t start time. Start time is 0. I'll decide the end time as 60. Then delta t is a time step that we take from start to end. Okay, so I will take it up as 1 second. Okay. And you will have time that starts with t start, and then you will have a counter I equals 0. You will say time less than equal to t end. Little set of things. Okay, and then you will have increment of I is 1. Now x of t is computed first. exp of minus time by t. The t was 0.5 that we took, which was a time constant. Okay, capital T, right? It's capital T. Yeah, so this is a time constant here. So this is your time constant. Measure of time constant. So if I have that here, so this is x of t. So once you have this x of t, then you'll compute the error. Error equals rt minus x of t. Then you will say capital X of I. You will make a vector and use a capital of I comma 2 equals rt, and x of I comma 3 equal to x of t. Capital X of I comma 4 equal to error. I have this time is equal to time plus delta t. Once I do that, I will check. So this if time is equal to, okay, I'll sample it. Maybe you call it at, so you took it from 0 to 60 seconds, we'll call it at some 50 seconds. Okay, when time is equal to 50 seconds, you can sample the value of displacement, which is the output displacement. So I'll say this num to string of, I'll take it as capital X. The error is given here, x of I comma 4. So I will take x of I comma 4. So that is it. There I will have this. Else you can continue the loop, and end is already there for while. Here I'll go for while. Okay. So this should compute the error for all points of time, starting with time t equals 0 to ending time at 60 seconds. Okay, so I can say So I will say this. I've got the same values there. Okay, so I'll say this of, okay, I'll disp time comma t in seconds again, and I'll have r of t. I will take x of t. For the next line, and time r of t x of t, and then I will have error meters. It has to be within the quote, some space here, and then I will have display command, and I'll say disp of x. So I'll display the entire vector x. Okay. All right. Let's take it for 10 seconds and then run the program. Okay. So what I've done is I've used the conditional statements and conditional loops to execute this value of x of t at all points of time, starting with time t equals 0 second to t n equals 10 second. Okay, so if I try to run this code, so there's an error here. So I've lost that as a bracket. Okay, I need another bracket here. Yes, the error got, the code had an error. Now the error is out. Okay, so it is still telling me that I've got, okay, here. All right, it's because of typos, typing mistake. I'm sorry. Okay, now we have it. Now you can see once we run this code, okay, so I'll run this code again. At time t equals 0, starting with time t equals 0 to 60 seconds, or okay, we did it till 10 seconds, right? Okay, till 10 seconds, 0 to 10 seconds, your input r of t is 1, and your output x of t starts with 0 and goes to 1. So that means for time t equals 10 seconds, the output of the system, closed loop control system, is same as the input of the system. So the error becomes 0. But if you start with time t equals 0, the error was maximum, as what we had discussed. But if you take a sample time of 0.5 seconds, suppose you take a sample time of 0.5 seconds, the error is almost 60%. Okay, so what you have done here is you built a logic. You see, you have just built a simple logic to estimate the error, which is the error force in a closed loop control system. So if you see that this is the error force that you computed. See, even without solving a differential equation, okay, you could estimate the error force, okay, using this approach. All right, and we have estimated the error at all points of time. Now, this table is for the time constant t taken to be 1 second. Okay. Now, if you take the time constant to be 0.5 second, right? What we'll try to do is rerun this code and obtain the new values of errors. Now you see, if time constant was smaller, I told you time constant is a measure with which you can see the system response. Smaller the time constant, it responds faster. So the error will become 0 within 5 seconds, as you note. Okay. So you have made a script, you have used a function. Maybe you can try to use a function, okay, to call the values from elsewhere to compute. Okay, you can say, I can make a function here. Okay, so I can say that this is a response function, so I'll call it as function x equal to B response of D x of P is equal to 1 minus exp of minus B of colon divided by 1, 1 divided by D of what is e power minus t by tau. T by tau is now tau is 0.5. Tau is 0.5. Okay, I'll give it as 0.5. That's it. So x of t is computed. So it's B response. I can save that as B response. So that's a function that you will have. Okay. Now once I have that, what I'll try to do is I'll compute this x of t. So instead of this x of t, I'll comment this. You can use percentage for comment. So r of t minus this. So I can call this as now new function name B response of pass this entire vector x. Okay. So I'll pass this entire vector x. Now take this, cut it up, and then be here. Now I'm calling the function now in the main script. Okay. So if I call this function in the main script and run it again, it has some errors. So go to line 29. X of I comma 1, I was 0 is time, and then R of t, x of 3 is this. X of t, d of 1 comma 1 divided by 4. Okay. All right. So you will have this B response function for which I could give this. Okay, I will give this as x of I comma 1 here, and I will have this as d. All right. So that should still you had some errors here. Okay, it takes x of t here. X of t is this. Okay, instead of x of t, I'll say B response of B. All right, so that should fix that. So I have, so in parenthesis problem, it's because of typos. So if I run that, yes, now I have the code that runs where I'm trying to call this function to evaluate the response, which is given by 1 minus e power minus t by capital T. Okay, so this is the error. So this way you have used the conditional loops, the conditional statements, then you can try to print the results. Okay, so you've built now a successful logic to execute the value of the force, the error force at all points of time. So what I've done is for c equals 1, so time constant t will become c, which is capital T equals capital C. Okay, and if that is equal to 1, we can rerun this program. C equals 1. Okay, so if I keep this as 1, all right, so if I keep this as 1 and rerun, you will see that there is this set of table that gets generated. Okay, so it starts with 1 and ends with 0. Okay, so that should do, right? Okay, so what I've done now is estimated the error using the logics. Okay, and Once I've estimated the error, I've computed the error for all values of time, right? So I'll try to conclude because it's getting late. My time frame is done. So what I've got as conclusion is that if you use a conditional loop statements, they form a strong basis for building the logic, okay? And your scripts and functions are systematic data exchange programs for efficient computation. So if you have an efficient computation, that means you can do a computation of x of t elsewhere in the function and then try to call it within the script. So this will give you an efficient approach to program. All right, that's it, I'm done. Thank you. So if you have